In this video, we're going to continue topic 3.1, which is the chain rule. So previously, we've worked with the product rule, quotient rule, and chain rule, but we worked with each of these rules separately. In these notes, we're going to work with two new ideas involving the chain rule. First one is repeated use of the chain rule, and then the second one is chain rules with problems that require a product or a chain rule or a quotient rule or a chain rule, and putting them together. So what you have to do is when you think about the repeated use of a chain rule is you'll notice you've got to think about the blow pop again, where you've got the inside function is the bubble gum, and then the outside function is the candy. Well, now you've got the wrapper on the outside, so now you have a function in a function in a function. Or if you want to think about it in peanut M&Ms because you like those better, or peanut butter M&Ms, you've got the outside candy shell, inside that you've got the chocolate, and inside that you've got the peanuts. You have a function in a function in a function. Okay, so before I try to take the derivative of 29a, I'm going to choose to rewrite it a bit. So f of x equals that sign. Whenever we see the squared on the trig, it's best to write it on the outside. So I now see that I have an inside function and another inside function, and then the outermost function is the squared. So I'm going to treat this as two separate kind of u subs here, or u's. So I'm going to say that my first u is this here. So u equals sine of 3x. And then I know that my original function, if I were to just rewrite that, I would get f of x equals u squared. And then I have to take the derivative of this orange one here, but I'm noticing, I'll use the rainbow colors, that there's another inner function. So I'm going to call that inner function, let's call it w. So w equals 3x, meaning that w prime equals 3. So remember, when I'm doing the chain rule, I need to take the derivative of the outside times the derivative of the, derivative of the inside times the derivative of the outside. So I'm going to do some substitution here and say that that's the sine of w. The derivative of that would be cosine of w. And then I'm going to substitute the w back in. Okay, and I have to multiply by the inside function. So really the derivative of, actually I should have done it here. So I've taken the derivative of the outside. I need to take the derivative of the inside, which is the 3. And then I need to substitute the w back in. So u prime equals 3 cosine of 3x. Now, we're going to come back to this original function here. I have to take the derivative of the outside, which is 2u. And then I'm going to multiply that by the derivative of the inside, which is 3 cosine 3x. And then we're going to replace the u. So f prime of x equals 2 times my original u, which was sine of 3x, and then times 3 cosine 3x. So we could rewrite that as 6 sine 3x cosine 3x. All right, we're going to try this again. So my next u looks like this one here. So I've got that u equals cosine 2x. And then I notice that I've got another u on the inside. So I'm going to call it w. So w equals 2x, meaning w prime equals 2. So to get u prime, I need to take the derivative of the, I'm going to rewrite it first. So u equals cosine of w. U prime equals the derivative of the outside function, which would be negative sine w, times the derivative of the inside, which was 2. And then we want to replace the w. So it would really be negative 2 sine of 2x. Now, I haven't taken the derivative of g yet. So g of x, when I replace the orange, I would get u. We take the derivative of the, that's a prime, take the derivative of the outer function, which would be e to the u, and then we multiply that by the derivative of the inside function, which we know is -2 sine 2x. And then we're going to substitute the u back in, so you get e to the cosine 2x times -2 cosine 2x. All right, I'm going to do it again here. I'm going to move some of my work off to the side. I'm noticing my u is this big mess in here. So u equals x squared plus tangent of 5x plus 1. I do notice that there is some more u action going on here, so I'm going to underline that in this purpley color, and I'm going to call it w. So w equals 5x plus 1, which means that w prime equals 5. I'm going to keep chaining it backwards now. So u prime equals 2x plus the derivative tangent is secant squared. Actually, I should have rewritten this. Sorry about that. Let me follow the steps in the right order. We are going to rewrite because we had an inner function. So we have x squared plus tangent of w. Okay. Now let's take that derivative. So u prime equals 2x. Derivative of tangent is secant squared w. And now we're going to substitute back in for the w. So u prime equals 2x plus secant squared of 5x plus 1. Now we're going to go back to our original here, and I'm going to rewrite the original, which would be g of x equals, I'm going to write it as u to the 1/2 power instead of the square root. Now g prime of x equals 1/2 u to the -1/2 times my inside function, which is the 2x, the derivative of the inside, secant squared times 5x plus 1. Now we're going to actually, before I replace my u, I'm going to move this back down to the denominator because negative wants to go downstairs. The numerator is going to stay exactly the same, 5x plus 1. And then when I've moved that down, I'm also going to go ahead and put it back into a square root. You don't have to. And then we're going to replace our u, which was this here. So x squared plus tangent of w. All right, we're going to do one more here. Again, I'm going to rewrite this one before I try to do it. So, and I don't know why it doesn't say f of x, g of x. Let's call it f of x equals. So f of x equals the cotangent of 3x over 2 to the 2/3 power. So my u has got to be the cotangent. So I'm going to say u equals cotangent of 3x over 2. Which means I have another inner function right here. So that I'm going to call w. So w equals 3/2 x, which means w prime equals 3/2. Now I'm going to take that and I'm going to rewrite u so I get that substitution done. So cotangent of w. The derivative of u then is the derivative of the outside function, cotangent w, times the derivative of the inside function, which is 3/2. Now we're going to come back to our original here. I'm going to substitute in my u, so u to the 2/3. To take the derivative, we take the derivative of the outside function, so that's going to be 2/3 u to the -1/3. And then the derivative of the inside function, which we found to be cotangent of w times 3/2. So I'm going to do a little bit of simplifying. I noticed that my 2/3 and my 3/2 are actually going to cancel. I also noticed this -1/3 power is going to go to the denominator. I never substituted my w back in, did I? So this really should have been 3/2 x. So let's fix that here too. And then I've got cotangent of 3/2 x over u to the 1/3 power, and then I want to substitute in the u to the 1/3 power, which is going to be, instead of u, I'm going to write cotangent of 3x over 2 to the 1/3 power.